Evening for the inauguration of the IIT JAM Mathematics Workshop, which is an online intercollegiate mini preparatory course for IIT JAM Maths. This workshop is organized by the Department of Mathematics at John Wilson Education Society's Wilson College, which is an autonomous college in Mumbai, under the DBT Star Strengthening Scheme from January 6th, that is today, to January 19th, 2025. Let me give you a small brief about JAM. JAM is Joint Admission Test for Masters, and this test, which is for undergraduate science students, has been conducted for the past 2 decades for subjects like biotechnology, chemistry, economics, geology, mathematical statistics, mathematics, and physics. It is a gateway to many of the premier institutes offering high quality postgraduate education. This year's JAM is organized by IIT Delhi, and one can find all the details related to this test on their official website of JAM 2025. So I have been assigned the task to welcome this gathering. On behalf of the Department of Mathematics, I first of all heartily welcome our Principal, Dr. Jamson Masih sir, Vice Principals, Dr. Anuradha Pense Madam, Dr. Ajita Kumar Madam, Miss Vinita Matthew Madam, and Dr. Ashish Usgare sir, IQAC Coordinator, Dr. Radhika Birmole Madam, Academic Dean, Mr. Mahesh Shetty sir, and DBT Coordinator, Mr. Michael D'Souza sir. We sincerely thank our principal, vice principals, IQAC and DBT coordinators, academic dean, and the college management for providing this wonderful opportunity of organizing this workshop. Next, I would like to welcome our esteemed resource persons of this workshop. Let me quickly introduce our resource persons. We have with us Dr. Deepak S. Jadhav sir, who is an associate professor at Srimati CHM College, Ulhasnagar. Mr. Mandar Khasnis sir, who is an associate professor at Srimati CHM College, Ulhasnagar. Dr. Ranjan Khatu sir, assistant professor at Arts, Science and Commerce College, Lanja, Ratnagiri. Mrs. UK Patne ma'am, assistant professor at VPM's BN Bandodkar College of Science, Autonomous Thane. Dr. Anand Chitrao sir, who is a postdoctoral fellow at Harish Chandra Research Institute at Prayagraj. Dr. Akshay Kumar sir, who is a postdoctoral researcher at Indian Institute of Technology, Madras. And Mr. Arvind Kumar Mishra sir, who is assistant professor at Thadomal Shahani Engineering College, Bandra. We sincerely thank each and every resource person for graciously accepting our invitation to contribute to this workshop. I also take this opportunity to welcome all the respected faculties of our college who are right now present in this meeting. Lastly, I welcome all the participants of this workshop to this inaugural program. We have received an overwhelming 496 registration responses from different states of India, such as Maharashtra, Gujarat, Sikkim, Kerala, Assam, West Bengal, Punjab, Uttar Pradesh, to name a few. We thank you all for showing your interest and registering. We look forward to seeing you throughout this workshop, and we really hope that it proves to be beneficial to you for your preparations for entrance exams. I now invite our principal, Dr. Jamson Masih sir, to officially inaugurate this workshop and address the gathering. Over to you, sir.
Yeah, Tina, can you hear me?
Yes, sir, you're audible.
Yeah, thank you. Good evening, everyone. And I give my approval to inaugurate this workshop with all of you who are present here. And it is both an honor and a pleasure welcome you all to this IIT Jam workshop, which has been organized by Wilson College Mathematics Department. And this event marks a significant steps in the academic journey of aspiring mathematics and scientists who aim to excel in one of India's most competitive examination. At the outset, I would like to extend my heartfelt gratitude to the organizing committee, especially the faculty members of Wilson College Mathematics Department, for their vision and efforts in making this workshop possible. Because I know that they were, involved to have this workshop since long, and now they have decided the dates. And these kind of initiatives underscore the college's commitment to academic excellence and its role as a guiding light for students pursuing their higher studies. Friends, the IIT JAM examination is not just a test of knowledge, but also a platform that opens doors to immense opportunities, be it in advanced research, cutting edge technology, or impactful teaching. Mathematics as a discipline is central to solving real world problems and advancing human knowledge. And I am delighted to see so many of you, as Tina has talked about, that 496 participants have registered. And some of you are here today. And all of you are eager to learn challenges yourselves and explore your potential. On the onset, this workshop is designed to provide a focused and strategic approach to preparing for IIT JAM with expert guidance from our faculty and guest speaker, which they have invited. Over the course of this program, you will not only deepen your understanding of concepts, but also gain valuable insights into problem solving techniques, time management, and exam strategies. And as she has mentioned that I have to inaugurate, as we all of us together inaugurate this workshop, I encourage each one of you to make the most of this opportunity. Be inquisitive participants actively and collaborate with your peers, those who are here for this workshop. Remember, success in any competitive exam requires perseverance, dedication, and a positive mindset. At the end, I would also like to take a moment to appreciate all my faculty members of Mathematics Department of Wilson College for their fostering a culture of learning and innovation. It is through initiatives like these, especially our HOD Virgie Jacob, Tina Thomas, and other faculty members, we are able to nurture future leaders in science and mathematics. In conclusion, I wish you all a productive and enriching experience in this workshop. Let this be the beginning of your journey towards achieving your dreams and contributing to the world of mathematics and beyond. Thank you once again, and best wishes to all of you. Thank you, and have a nice day. And I declare this workshop open.
Thank you, sir. Thank you very much for your encouraging and kind words. It is definitely an inspiration for us. Thank you for all the support and guidance. I once again thank all the esteemed dignitaries and resource persons who are present in this meeting, who have graced this occasion with their presence. I also thank all the participants for attending this workshop. So we have come an end to our inaugural ceremony. We shall soon start the workshop session of day one. So I request the participants to stay in this meeting. Otherwise, this inaugural program has come to an end. Thank you so much for attending this meet. So for today, our session host is Dr. Bridgie Jacob, who is the in charge head of the Department of Mathematics at Wilson College. Over to you, ma'am.
Yeah, good evening to everyone. Um, I think we should wait for 5 minutes more so that we can have more participants to join. If that is okay with you, Akshay sir, so we'll wait for 5 minutes.
Yeah, yeah, sure. We can wait for some 5 more minutes.
Okay, sir, thank you.
Actually, I was unable to switch on my camera, my mic.
Yeah, yeah. Tina ma'am, please make Akshay sir the co-host.
Okay, ma'am.
Hello, Akshay sir, the time the students are joining, if there is any PPT which you want to share or
Ma'am, your voice is not audible. Can you repeat this again?
Sir, I was saying by the time the students are joining, if there is any PPT or screen which you have to share, you may have those initial setups done so that we may soon begin.
So actually, I don't have any PPT, so I will write everything on the iPad.
Okay,
So
yeah, no
for that
problem.
and for that, I need to switch off my camera also. After introduction, I will switch off my camera.
Okay, sure.
Otherwise, the roof will be visible on my camera, so it will be weird.
Okay.
So after introduction, I will switch off my camera and I will write everything on the screen.
Good evening to one and all. I welcome all the participants and I welcome today's resource person, that is Dr. Akshay Kumar. Is a postdoctoral researcher at IIT Madras. He has done his master's from IIT Madras and his PhD from MNIT Jaipur and currently pursuing his postdoc. Sir's area of research is functional analysis. We are glad to have an expert like you, sir, to guide our students in order to prepare for IIT JAM. I hope these participants will take this seriously and prepare for JAM and come out with colorful results. So over to you, sir.
Thank you, ma'am. I hope I am audible to everyone.
Yes, yes, sir.
So thank you, ma'am, for introducing me. So am I visible to everyone? I don't know.
Yes, sir, you are visible.
So thank you, ma'am, for introducing me. And let me share my screen. Is my screen visible to everyone? So please, someone answer.
Yes, sir.
Yes.
Okay. So today I will let me switch off my camera. So today I will talk about functions of several variables. So in particular, I will talk about functions of two variable and three variable. So because this is in the syllabus of JAM. So I believe that you all know calculus of one variable. So anyway, I will repeat most of the things, but I believe you all know calculus of one variable. So suppose you have a function. So let's start with the starting point limit of a function. So in one variable, suppose you have a function. Suppose you have a function from R to R. So you have studied limit of one variable function in probably in 11th or 12th class. So suppose there is a point, say A in R. So you must have seen left hand limit and right hand limit. So what were these things? So left hand limit was, so take limit s tends to 0, s is greater than 0, f of a minus h, right? And right hand limit is limit s tends to 0 and s is positive, f of a plus h. So right. So suppose this is your point a, right? And suppose this is your function f. This is your x. This is your fx. So what we were doing in left and right hand limit is, so if h is positive, so a minus h means this is point a minus h. If h is positive, that means a plus h is this point, right? So we actually approaching this point a in left hand limit. What we were doing, we were approaching this point a from the left hand side, right? And we were looking at the function where this function is going. That that called left hand limit, right? Similarly, if you approach the point A from the right hand side, then where the function is going is called the right hand limit, right? So if both the limits are equal, so in this case both are equal. If left hand limit and right hand limit both are equal, then we say the limit of this function at point A is exist, and this is actually equals to left say since both are equal, we can say left hand limit or right hand limit, right? So if you have, suppose you have this type of case, suppose this is a point and this is your function, and say this one. So from left hand side, function is going to this point. So left hand limit is this point, this value, and from right hand side, function goes to value is going to that this point. So that means left hand limit and right hand limit are not equal. So in this case, we say limit at this point does not exist. These things we have seen in 12th or 11th class in our higher studies, in our secondary educations. So, so suppose your function is now from R to R. Now you have two variable function. So let me draw the domain. Suppose this is your R square, and point will be of the form A comma B, right? So in R function, if function is from R to R, and we have any point, so we have only two choice there to approach this point. So one is from left hand side, another one is right hand side, right? So now suppose your point is this A comma B in R2. So in this case, from how many ways we can approach this point? So let's see this. We can approach this point from in this way. We can approach this point in this way. We can approach this point in this way, this way, this way. And if some person say, I will approach this point from this way. So that's also a way to approach this point. Someone can approach this point this way. So you can see we have uncountably many. So you can say infinitely many directions, paths or directions to approach this point. This point A comma B. And of course, we cannot cover each direction in the way we were doing in one variable, right? So the problem is, so we need a proper definition. So this is the motivation actually why we need a proper definition, right? So so in one variable, the definition is, suppose your function is from R to R, right? And suppose A is any point in R. So we say limit x approach to A, f of x is equals to L. L is any number, real number. If you give me any epsilon, if for every epsilon greater than 0, you give me any epsilon, so I will be able to find a delta. There exists a delta greater than 0 such that the quantity mod of fx minus L will be less than epsilon. This is whenever mod of x minus A is less than delta. This is the definition. This is the proper definition of a limit of a function, right? So what we are actually doing in this thing, right? So if you observe this quantity, so this is actually x minus A is less than delta, bigger than minus delta. So that means your x belongs to A plus delta and A minus delta. So if you observe this, so suppose this is your point A, So this is your point A minus delta. This is your point A plus delta. So you have covered all these points, right? So you have covered left hand direction also. You have covered right hand direction also, right? So this is the proper definition of a limit. So we can generalize this definition to two variable function also, right? So suppose you have function from R2 to R, right? And you have a function a point A comma B in R square, right? So we say, as we have done in one variable case, so we say limit x comma y goes to A comma B, because this is two variable function. So f of x comma y is equals to L. This since this function is from R square to R, so L is a real number. We say this limit is L if the same thing we will do as we have done in one variable. If for every epsilon greater than 0, you give me any epsilon greater than 0, I will be able to find there exists a delta greater than 0 such that the mode of this quantity, mode of x comma y minus L, is less than epsilon whenever the mode of, in one variable what we have, mode of x minus a is less than delta. So here we will have x comma y minus a comma b is less than delta, right? Okay. So if you observe this quantity, so what we are actually doing in this quantity. So if you observe this quantity, so what is the distance between x comma y and a comma b? So this is actually under root of x minus a to the square plus y minus b to the square is less than delta. This is what we are doing in this quantity. So if you solve this quantity, you can observe that this is x minus a to the square plus y minus b to the square is less than delta square. So what this equation represents, this is actually a circle with center a comma b and radius delta. Delta is a positive number, right? So if you see this thing, so suppose this is your a comma b. Let me change the color. So this is your point a comma b. Then this represents this circle. Okay. So whatever direction you choose, after a step, this direction will be inside this circle, right? So whatever direction you choose, after a point, this will be goes to this circle only. Okay. So that means we have covered all the possible directions. Right. So that means, so this definition makes sense, right? Similarly, we can do for three variable function. So suppose you have a function, even you can generalize this the same definition for n variable functions. Even you can uh, generalize this definition for metric spaces and topological spaces also. For topological spaces, you need to care about open sets, but for metric spaces, you can do these things. So suppose you have a function from R3 to R, right? And you have a point in domain, say A, B, C belongs to R3, right? So we say limit. So here we have three variables, x, y, z goes to A, comma, B, comma, C, f of x, comma, y, comma, z is equals to limit. This limit is L if for every epsilon greater than 0, there exists a delta greater than 0 such that this quantity mod of x, y, z minus L is less than epsilon whenever this quantity mod of x, y, z. So in two variable, what we have x, y, distance between x, y and a comma b. So here we will have x, y, z minus a, b, c is less than delta. Now, in this case, if you observe this thing, so this will be x minus a square plus y minus b square plus z minus c square is less than delta square. What this equation represents? This is actually a sphere with center a comma b comma c and radius delta greater than 0. So suppose you have, let me change the color. So suppose you have this x, y, and z, right? Suppose here you have this point a comma b comma c, right? So you have considered this sphere. So this is actually a sphere, right? So whatever path you choose, whatever direction you choose, after a point you will be in this circle. That means you are covering all possible directions, right? And this delta is depends on the epsilon you have chosen, right? This delta is not independent of epsilon. It depends on your epsilon, right? So if you take, suppose if you take example, suppose, so we can take example in one variable case. Suppose your function is f(x) equals to x square, right? And you want to prove that limit x tends to 0 of f(x) is 0, right? So the first condition is you give me an epsilon greater than 0. This is epsilon greater than 0. This is given, right? So our aim is to find a delta such that this satisfy this condition. So we need to find a delta such that the delta should satisfy this condition, right? So our function is x square minus, so x square. So we want to prove that limit at x tends to 0 of f of x equals to 0. So our epsilon greater than 0 is given. Now, what we want, so this function x square minus 0 is less than epsilon whenever mod x minus 0 is less than delta. We need to find this delta, right? So let's simplify this function. So this is mod x square is less than epsilon, right? This is equals to mod x less than root epsilon, right? Now, if you choose this delta is under root epsilon, so this delta will work, right? Whenever mod x is less than delta, so this will imply mod x will be less than root epsilon. So this will imply x square will be less than epsilon. This is what we want, right? So this is actually simple function. So we can calculate it. So in general, it's not easy to prove limit of function by using epsilon delta form. The definition which I have just given you using epsilon delta definition. So in general, it's not easy to prove even it's not easy to find a limit of a function by using this epsilon delta definitions. So what should we do? So what should be our next step? So for that, we actually use some properties and some called algebra of limits and all these things. So the next point is how to find limit of function. So if we understand this point, so we will be able to find the limit of a function. So the first point is, so so suppose you have a polynomial in two variables. So the limit x y tends to a comma b of this polynomial is always equals to, just put these points at the place of x comma y. For example, if you take the polynomial is equals to pxy equals to x square plus y square, and you want to calculate limit at x comma y tends to a comma b of this polynomial. So this will be equals to, for this polynomial we are doing, so this will be equals to a square plus b square. You take any polynomials, it will work there. So I'm not going to prove this, but this is actually an important fact we use while calculating the limit of a function, right? You take any polynomial, even if you take polynomial into three variable, this is a polynomial in three variables, then limit x y z tends to a comma b comma c of this polynomial will be equals to polynomial a. Just put values of just put x equals to a, y equals to b, and z equals to c, right? So now you can compute, suppose limit xy tends to say 1 comma 0, and if I ask you xy 0, you can calculate limit xyz tends to 1 comma 1 comma 2, say x square plus y square plus z square. You can calculate this also. Limit xy tends to 0 comma 1, so xy plus xy square plus y x square. Xyz tends to 1 comma 0 comma 1, xyz plus z square plus x square, and you can any other polynomial in this. So can anyone tell me the answer of first one? If you are following me, so please someone tell me the answer of first one. Are you following me or?
So they're replying as 1.
Okay, so this is 1. And similarly, you can do this one. So this will be 1 plus 1 plus 4. So this will be 6, I think. And similarly, you can compute these things also, these 3 and 4 also, right? So these are actually easy. Now, so what else we can do? So these are actually easy functions. So we can uh, just put values of x and y, and we can calculate the limit of these type of functions, right? So what else we can use? We can use is, second one is algebra of limits. So first, suppose limit x, y, or you can add z also here at a comma b. F of x comma y is, suppose this is L1, right? Similarly, limit x, y tends to a comma b, z of x, y is equals to L2, right? So both are exist and equals to L1 and L2 respectively. So what can you say about limit x, y tends to a comma b, f plus g? So this will be if both f and g are exist, then f limit at a comma b of f plus g will also exist, and this will be equals to L1 plus L2. Similarly, limit a comma b f minus g will be equals to L1 minus L2. Limit x, y tends to a comma b, f into g will be equals to L1 into L2. And similarly, x, y tends to a comma b, f upon g. What can you say about this? What can you say about this quantity? What can you say about the limit of limit? So let me write it. So what is the limit of f upon g at point AB? So can anyone please answer this?
L1 by L2 given L2 is not equal to 0.
Yeah, that's correct. L1 upon L2 provided L2 is not equals to 0. If L2 equals to 0, so if L2 is 0, so then
Limit does not exist.
so it depends actually,
Then if
right?
L1 also 0, then 0 by 0 L orbital rule.
Yeah, yeah. It depends. You cannot say anything precisely for f upon g, but it actually depends on L1. Whether L1 is 0 or L1 is not 0, it totally depends on L1, right? And so here I mentioned that. So suppose you have, so I can write as a remark here. So in the first point, I have mentioned that. So if f and g both are exist, then f plus g is also exist, right? Limit at that limit. I'm talking about limit. If limit of function f at point a comma b is exist and equals to L1, and similarly limit at point a comma b of g is equals to L2. So we have mentioned that limit at point AB of f plus g will be L1 plus L2, right? So suppose I'm saying limit. So even I can talk about one variable function. So x tends to a of f of x, and I'm saying limit x tends to b of gx. They both are does not exist. Limit are not exist. So then what can you say about limit x tends to a f plus g? So what can you say about this function f plus g? I'm saying both limit are not existing, right? So what can I say about the limit of f plus g at point A? Think about it.
Does not exist.
Okay, some persons are saying does not exist. Is
We
there anyone
can't
who will say,
we can't say.
yeah, we can't say anything. So let me give you an example. So suppose you take f of x equals to sine square 1 upon x, right? And take gx equals to, this is a, I can say this is the simplest example I can give you. So limit x tends to 0, sine square 1 upon x. This does not exist. I hope you know this. Right. Similarly, limit x tends to 0, cos square 1 upon x. This also does not exist. Now, what can you say about the sum?
Equals 1.
Yeah, it always exists.
Yes, sir.
This is 1. So, it may or may not exist. Right. So, answer is this may or may not exist. But even you can conclude something more than that. Suppose this limit exists. So, it actually independent of first point. And this is first point. So, this is second point. So, suppose this limit x tends to a f of x. So you can say
double tap.
सर आवाज नहीं आ रही आपके.
am I audible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So if this limit exists, so only two options are possible. So first one is either both the limit.
Sir, your voice isn't audible again.
Now, is it audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So only two options are possible. So first one is either both limit will exist. If both limit will exist, then by algebra of limit we can say the sum limit of sum of the function will also exist. If this is exist and one of them is not exist, then other will also will not exist. It won't happen that the sum limit of this sum is exist and the first function limit at that point of first function is exist, but at the same time limit at the same point of the second function is not exist. It won't happen. Even you can prove these things. Now, what can you say about the Suppose this limit exists. So what can you say about these things? Limit x tends to a f of x. Can you say the same thing for the product also?
No, sir.
So can you give me an example?
X and 1 upon x.
Okay. So at
When
what point you are
to 0.
so, okay. So you are saying if this limit exists and this does not exist, then still the product limit may exist, right? It may happen that the limit x extends to a f x exists and limit extends to a g x does not exist. You can take this example, suppose f of x equals to you can take f of x equals to x, right? And you take gx equals to 1 comma minus 1. So x belongs to q and x belongs to does not belongs to q, right? So this limit exists at every point and this limit does not exist at every point on R. So but product limit at 0 f into z. So f into z will be x if x belongs to q minus x if x belongs to does not belongs to q, right? So this limit will be equals to 0. Limit exists and will equals to 0, right? So the thing the conditions we have mentioned for some case so may not work in the product case, right? And you can generalize these things. The same thing will work on two or three variables also, right? So this is the algebra of limit. And and I can tell you one more property. So motivation comes from this function also, this function only. So what's special in this function? We said okay, fx equals to this limit exists, and we take this function gx equals to 1 and minus 1 when x belongs to q and x does not belongs to q, and we say so limit of the first function is exist, limit of the second function does not exist, but still the product limit of the product function is exist. So what's the special in this second function? Is there anything special in this function? So you can observe that this function is actually a bounded function, right? So even you can prove that suppose you have limit x tends to a f of x equals to say this is 0, okay, and g is any function which is a bounded function. Bounded means there exists m greater than 0 such that g of x will be less than equals to m for all x belongs to R. Even I'm taking globally bounded, but if it is bounded in some neighborhood of that point A, that also works. But here we are taking it's bounded on the whole domain. So then, if we have these conditions, then limit x tends to A, f into z will always exist and equals to 0, right? Even in two variable case, what can we say? Suppose limit xy tends to a comma b f of xy. Suppose this limit is 0, right? This is our assumptions. and g is any function from R to R such that this is a bounded function. Right? So bounded means in two variables there exists m greater than 0 such that this g of x comma y is less than equals to m for all x y belongs to R square. Right? If these conditions are given, then limit xy tends to a comma b f of xy into g of xy will always exist and equals to 0. Right? And you can even these things also working for three variable also. You can write z here also, so it won't affect anything here. So and even you can mark this property as important property. This is very important property. Right? So now my question is, so I have written everything for this limit equals to 0. The question is, what will happen if limit x tends to a of fx is not equals to 0 and g is a bounded function? Of course, I'm talking about R to R. So there is nothing special in R square. So it's the same thing will work for R square also. So suppose we have given this condition. So what can we say about the limit of this function? What can we say about this function? Can anyone please answer me? I hope I'm audible to everyone.
So it depends on the limit of fx, no?
That's what I'm asking. Suppose this is not 0. I'm giving you this is not 0.
We can't conclude anything, sir.
Yeah. If
There is
suppose
multiplication.
yeah.
So
Sorry. So it depends. Actually, it depends on the limit x tends to a gx, whether this limit exists or not. If it exists, then we can say this product will also, the limit will also exist for product case also. If it will not exist, then again we have to check for what the function is, where this function is going, and all these things. Right? So now, and we have one another. So how to use this property? So yeah, I can give you some examples. So suppose I am saying calculate the limit of this function xy tends to 0, 0, and I am giving you function mod x plus mod y sine x. It's not look nice, but if you use the property I have just given you, so this function is, this is always less than equals to 1, right? So this function is actually bounded function, right? And this is a one variable function, and limit x goes to 0, right? So sin x goes to 0. So this limit this is equals to 0. right? So this is one example. So let me give you some another example. Limit x, y, z tends to 0, 0, 0. And I'm giving you function cos x, y, z upon 1 plus x square plus z square into x, y square. What can you say about the limit of this function? So use the property just I have just given you. So the cos is always a bounded function, and the value always lie in between -1 and 1. So this function is actually a bounded function. Cos xyz upon 1 plus x square plus z square. This value is, you can take mode of this, is always less than equals to 1, right? And this is a polynomial, right? So the the moment we have polynomial, just put the values of the where you are calculating the limit. So we are calculating limit at the point 0, 0, 0. So that's just put the value x equals to 0, y equals to 0. So this will be 0. You just take this function as g, this you take this function as f. Right? G is your bounded function, and limit of f at 0, 0 equals to 0. So the product limit of the product function will be 0, right? Now, what else we can do? So what else we can do is, so next one is, so we can say property. So it's actually similar to the previous one. So it's called squeeze principle. So for one variable, I hope you know what squeeze principle is. So let me write the statement. So suppose you have three functions. Suppose f you can take in two variable, or you can take in three variable, or in one variable. It's up to your choice. So I'm taking in two variable. The same thing will work for three variable and one variable also. Suppose you have three function f, g, and h, and you have this relation, right? And I'm giving you one extra condition, that is limit x, y tends to a comma b. F of x, y is equals to limit x, y tends to a comma b h, x, y. This both the limits are equal and equals to L. These are our assumptions. Then limit at point x, y tends to a comma b of g will exist and equals to L. So because it lies in between f and g, that's why it's called, it's the principle called squeeze principle, right? So this is also one of the important result. I'm not going to prove this, but it's actually an important result. So I've just mentioned that the property I mentioned, suppose f limit. So let's talk about one variable function. Suppose this is 0 and g is bounded function. So suppose this is if and then I said this limit will be, the product limit will be equals to 0. So can we prove this statement by using squeeze principles? Yes. So suppose z is bounded. So we can prove, so z is bounded. So there exists m greater than 0 such that mod of g of x is less than equals to m for all x belongs to R or whatever domain you are taking, right? So from this, what we can say? So mod of fz is less than equals to m times mod of f, right? From this point, what we can say? So fz will be lies in between f comma m comma f and comma f. So what will happen? Yeah. So since limit of this function is going to 0, right? So this limit will also goes to 0. Limit of this function will also goes to 0, right? And so by squeeze principle, limit of this function will also goes to 0. This is actually the proof of this property, right? Even in algebra of limit, you can add one more property. Here you can add one more property. So if alpha is any non-zero number, so limit xy tends to a comma b, alpha times f will be equals to alpha times L1. You can always multiply a non-zero number. Zero case is not in an interesting case. That's why I'm not mentioning that. Right. So, and one more property I can tell you. Suppose f is any two variable function. Don't worry, we will see many questions after this. So suppose f is any function from R2 to R, right? And g is any function from R to R, right? So, and I'm saying this function is continuous. This is a continuous function. This function is a continuous function. For one variable, I hope you all know what is a continuous function. So I'm assuming this is a continuous function, right? So then, and also I need suppose and limit x y tends to a comma b of x y. This limit exists. Then limit x y a comma b. So I can talk about g composition with f. I can talk about this, and so I should write yeah. So okay, g composition with f is always equals to z limit x y tends to a comma b f of x comma y, right? So let me give some example of this property. Suppose you want to calculate limit xy tends to 0 0, and you have function sine x square plus y square upon 1 plus x square. So what is the limit of this point? So now take your function z of x equals to, so you can take z of x equals to sine x f of xy is equals to x square plus y square upon 1 plus x square, right? So see, the limit of this function at 0, 0 goes to 0. This is a polynomial. Again, this is a polynomial. Limit of this function goes to 1, right? So what is the limit of the f upon g? Will be 0 upon 1, so equals to 0, right? So what we can say about limit of xy tends to 0, 0 sine x square plus y square upon 1 plus x square is equals to. So this, because sine is a continuous function, so we can write is sine limit x comma y tends to 0, 0 x square plus y square 1 plus x square. So this limit is 0. So this will be equals to sine 0, and this will be equals to 1, right? So again, we can solve limit
Sir,
x, y
sine
tends.
0 is 0 na?
Oh, sorry. Thanks. So I was writing for sine, and in my mind I had cos. Sorry. So suppose you have limit 1 comma 0, and you have a function exponential of, so you can say e to the power of x square plus xy plus z square upon 1 plus xy plus y. Okay. So exponential is always a continuous function in the domain, right? So you can write this is a continuous function, right? So we can write this limit will be equals to exponential of limit xy tends to 1 comma 0 x square plus xy plus z square upon 1 plus xy plus y. So what's the limit of this function? Please calculate this limit.
1 plus z square.
It will be 1. Oh, okay. So this must be y square. Because there is no z in the question. We are dealing with r square.
Sir, 1.
So
1.
1.
okay, so
1.
most of the people are saying this limit will be 1. Okay, so most of you are saying 1. So I believe you, and this will be equals to e, right?
Yes, sir.
And okay, so let me ask you some question. So calculate this limit xy tends to 0, 0 sine exponential x square plus y square plus cos x y. Calculate this limit. So whenever you are calculating limit of any function, try to split that function as much possible as you can. Split that function. Try to split that function and calculate the limit of individual part. So that's the technique how to calculate limit of function. So here, so I can write here this limit will be equals to sine into limit of xy tends to 0, 0 e to the power x square plus y square plus cos xy, because sine is a continuous function, right? So again, exponential is a continuous function, so I can write sine e to the power limit xy tends to 0, 0 x square plus y square plus cos x y. Right. By algebra of limit, what I can write here, sine e to the power. I can split limit in the sum part, so it will be equals to limit xy tends to 0 0 x square plus y square plus limit over this limit xy tends to 0 0 cos xy. Right. Since cos is a continuous function, so again we can write sine. What is the limit of this? This is 0, right? X square plus y square. So e to the power 0 plus cos is a continuous function. Cos limit xy tends to 0 0 xy. So this is polynomial x into y. Just put the value of x and y. So it will be 0. Cos 0 is 1. Oh, sorry. Okay. So yeah. So this is 0 and this limit is 0. Cos 0 is 1. Sine this is equals to e to the power 0 plus cos 0 1. So this will be equals to sine e. Right? Are you following me?
Yes, sir.
Yes, sir.
Okay. So what else I can ask you? Okay, you can try this one. So find this limit. Limit xy tends to 0 0 cos sine x to the power 1000 y plus e to the power x square into x. Calculate this limit. Take 1 or 2 minutes and calculate this limit.
Zero.
Okay. So 1. How
Zero.
you got 1?
Sir, answer is 0.
Yeah, the correct answer is 0. See, this function is a bounded function.
Yes, sir.
So cos is always a bounded function, right? This is function f, this is function g, right? So limit xy tends to 0 0 of g. So I should write this is z, this is h. This is f. So limit of this function f is 0 because this is polynomial, and g is a bounded function. So the property I have mentioned earlier, by that property limit xy tends to 0 0 cos, so whatever it is written there into x will be 0. Now you got it?
Yes, sir.
These properties are actually very important properties. Even I can assure you, you can solve most of the questions by these properties. So let me ask you one more question. Solve this limit. Limit xy, this is z, goes to 0 0 0, and your function is mod x plus y plus z upon 1 plus. So you can say something 10 plus mod x plus y plus z into cos e to the power. So that x y plus z square. Now calculate this limit.
0, sir.
Yeah.
0, sir.
Again, the same technique is working here also. So this function is actually a bounded function, right? And this is, and suppose this is f, this is z. So g is bounded function, and limit zero 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 cos xy plus z square. This is equals to 0. So by our property, this will imply limit x,
one,
y,
sir.
z.
1.
Why 1?
Cos
Cos
0
0
by
1
Okay,
na.
okay.
Cos 0 1
So
sir.
this,
G
okay.
with G's limit will
Okay,
be
you can
1.
write x here. Okay.
Here f is bounded.
Okay. So okay, without x, we can solve this. Now the limit will not be equals to 0. Yeah, still the limit will be 0. Okay. So now try to solve this part. So see, mod x plus y plus z upon 10 plus mod x plus y plus z cos xy plus z square, right? So limit xyz goes to 0 0 0, right? So we can split this limit into parts as limit xyz goes to 0 0 0. Since mod is a continuous function, so we can write as x plus y plus z upon 10 plus mod limit x y z 0 0 0 x plus y plus z, and limit
But
cos
sir,
is a
mod
continuous function.
not continuous at x equal to 0.
So we are doing it's not 0 only, right? So okay, so this limit is equals to 0. Even mod of x is equals to x. If x is greater than 0, x is minus x is less than 0, equals to 0. Mod is continuous everywhere. Mod is this type of function. Mod is continuous everywhere, right?
Yes, sir.
So this is limit x, y, z goes to 0 0 0 x, y plus z square, right? This part is 0, this part is 0, this part is 0, right? So at the end, what can we say? That this is mod 0 upon 10 plus mod 0 plus into cos 0. So in total, it will be 0, right? Are you getting me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Oh, okay. So let's move to other things. So now most of the limit will be you can calculate most of the limits by these things only, right? So what will happen if nothing will work? if nothing mentioned above work. For example, I give you one example. Limit x y tends to 0 0, right? X square upon x square plus y square. What's the limit of this function? So nothing is working here. The thing we have discussed till now is is not going to work in this case, right? Because it's something 0 upon 0 type case, and right. So what should we do in this type of case? So here we need to check if nothing mentioned about, uh, or I have told you before this point. So if nothing is working, so what should we do? So at this point, you should check whether limit xy or xyz, you can take any point, at point AB of fx. If nothing is working, whether this limit exists or not. Xy. If your function is in simpler form, you just calculate the limit of that function. If you are not able to calculate the limit of that function by using simple properties, you should check whether the limit of that function is exist or not. So how to check? So as I mentioned in the starting of this session, so in R2, so first let's talk about R. So suppose you have any point A, right? When you say limit x tends to A of f of x does not exist. When you say this limit does not exist, if left hand limit not equals to right hand limit, right?
Yes,
But
sir.
but on R square, we have uncountably many paths or directions or to approach this point, right? So what you need to do is just find, just find two paths, or you can say directions, say P1 and P2, such that the same thing, the limit xy tends to that point A comma B of f of xy. This is along path 1, along path P1, is not equals to limit xy A comma B f of xy. This is along path P2. If the if you are able to find two paths P1 and P2, and for those paths limits are different, then you can say limit x tends to xy tends to A comma B f of xy does not exist.
X tends to A, B இருக்கும்போது
Sorry, what happened? Means I have written similar to this.
not equal to f of x along p2.
What happened? Feel free to say. I think everything is fine. And similarly, you can say for R3. Similarly, you can I'm not going to write everything again. Similarly, you can do for R3 also. Okay, so let's go back to the same question. Xy tends to 0, 0. The function was x square upon x square plus y square. Okay, so let's take this path. P1 equals to P1 path is y equals to x. So suppose this is my point 0, 0. Okay, so I'm approaching this point by y equals to x, the straight line. Okay, and again I'm approaching this same P1, and P2 is y equals to minus x. Okay, minus x won't work here. So suppose y equals to 2x. Okay, so suppose I'm approaching P1 and P2, right? So along this path, so along P1, the path P1 is y equals to x. And remember this, always remember this, these two paths must contain the point where we are checking limit. You can't take any path going in this direction. The path must contain this point. So both the paths P1 and P2 are containing the point, right? So suppose the path P1 is y equals to x. So along this path, so since limit y equals to x and x is going to 0, so y is also going to 0. So xy going to 0, 0. So just put y equals to x in the given equation. So you will have x square plus x square, right? So at the end you will have x square upon 2x square, right? So equals to 1 by 2, right? Now check along P2 path. So suppose the path is, now the path we have taken is y equals to 2x. Now y equals to 2x. So limit xy tends to 0, 0, right? So x square upon x square plus 2x square. So this will be equals to limit xy tends to 0, 0, x square upon this will be 5x square, right? This is 4x square, this is x square, this will be 5x square. So this will be 1 upon 5. Both are not equal, right? So we can say limit xy tends to 0, 0, x square upon x square plus y square equals to limit does not exist. Okay. Now it's not easy to find different paths always. So you have to work on this. So as much as you can practice, do practice. By practice, you can get these paths. It's not easy to find paths. So now suppose, let me give you some other questions. Limit xy tends to 0, 0. So can you try this one? X square plus y square upon x square plus 2y square. Try this one. What happened?
Sir, we are not able to see the screen.
Yes, sir.
The limit does not exist.
Hello? Hello, am I audible?
Yes.
Yes.
Yes, sir.
Yes, sir.
No, what happened? I don't know, the screen just turned off. Is my screen visible?
Yes.
Yes, sir. Yes, sir.
Okay. So, okay, I was talking about this function. X square
Does
plus
not
y square
exist.
upon. Yeah. So what paths you have taken? So I am interested in paths only. So you
Same
can take this
previous one.
general path. So
Sir,
just
sir.
take this general path, y equals to mx. Okay. So m can
Then
be 1 or 2 or anything. Just take this general path. If you take m equals to 1, if you take m equals to 1, you can take that path equals to p1. And if you take m equals to 2, you can take that path equals to path your path 2. So, but in general, you can take this path in general, general path y equals to mx. So let's do what will happen along this path. So this limit goes to 0, 0. Along this path, just put y equals to mx. So this will be m square x square upon x square plus 2m square x square, right? This will be equals to x square 1 plus m square upon x square 1 plus 2m square, right? Now you can cancel out x square. So now there is no x and y in the remaining part. So this will be equals to m square 1 plus 2m square. Now if you take m equals to 0 as your path p1, so your value will be 1. Now if you take m equals to 1 as your path p2, then your limit will be, this value will be, this is your, and your limit will be
2
1
by
plus 1,
3.
2 upon 2 upon 3, right? So you are having two different limit along two different paths, and paths are also containing the points. So in this case, again, you can say limit does not exist. Right? Now let me ask you this question: limit x y tends to 0, 0. So you can say xy square upon x square plus y to the power 4 into x. Try this one.
zero.
Okay, someone is saying 0. How you get it? Get this?
Sir, take path x equals to y square.
So you are taking path, okay. So you have taken path x equals to?
A direct also we can do it is a separation by separating both of them.
Can you repeat this again? What property you are using?
So 1 second.
Okay.
Sir,
Take 1 or 2 minutes. Okay. Someone was.
Sir, we have
Sir,
effective
by
degree of
separate.
numerator greater than effective degree of denominator.
Then wow. Then you can't say anything in that case.
So no, sir, by separating limit
So which part you are separating? That's what I'm asking.
Sir,
numerator
by
and
taking
denominator.
F and G.
Okay, okay. Just tell me F and G. What is your F and what is your G?
F is equals to X and G is equals to XY square upon X square plus Y raised to 4.
Okay.
Uh,
Then
and here G is bounded, so we can use that
okay.
property.
Yeah. So in that case, what will be the limit?
0.
Okay. So the right answer is 0. So how this function is bounded? The point is, you just told me this function is bounded. I'm asking why this function is bounded. That is correct actually. But I'm asking why this is bounded.
Because it's a polynomial.
Polynomials are not bounded in general. Just take fx equals to x. This is not bounded. This is a polynomial. If every polynomial is bounded, then I think you are claiming that every continuous function is bounded. That is a very big claim. Because you can approximate every continuous function by polynomials.
Sir,
Take 1 or 2 minutes, think about it, why this function is bounded. Answer is correct. The logic is also correct. The property you are using is also correct. The
sir,
point
if
is
we
why
take,
this function is bounded. So
sir,
the
if
term
we
in
take y
denominator.
equal to mx,
Huh?
sir,
Which
if we
scalar
take
term?
y equal to x, then it converts to 0.
Sorry, can you repeat that again?
Sir, if we take y equal to mx, limit x tends to
Okay.
0, then the whole limit is converts to 0.
Then
The whole g limit g is converts to 0.
why? Along one path you are saying the limit is going to 0. Then you can't say the whole limit is going to 0.
Okay, sir.
So because sir, denominator is greater, sir.
Why that is? That's what I'm asking. Why that?
Degree of
Power, the
Okay.
degree is
Okay.
numerator.
Let me tell you.
Sir,
So
by
have you seen this
AUGM
property?
inequality, we
So
can see.
suppose, okay. So let me tell you this property. So have you seen this property? Suppose A is any positive number. B is also a positive number. Even this is true for non-positive numbers also. You don't need. So suppose A and B are any two number. Okay. So even you can say these are non-zero numbers. Nothing is interesting in 0. So mod of this quantity AB is always less than equals to A square by 2 plus B square by 2. Have you seen this property?
No, sir.
This is A plus B to the whole square. So if you take A plus B to the whole square, this is always greater than equals to 0. So this will be equals to A square plus B square plus 2AB. This is greater than equals to 0. So that means you are saying A minus of AB is less than equals to A square by 2 plus B square by 2. Right. Similarly, if you take A minus B to the square, this is also greater than equals to 0. This is, so from this what you will get? So A square plus B square minus 2AB is greater than equals to 0. Right. So this will imply AB is less than equals to A square by 2 plus B square by 2. Right. So mod of AB will either be equals to AB or minus AB. Both quantity are less than equals to A square plus A square by 2 plus B square by 2. This is just whole square of A plus B. Right. Get it? So how to use this property in this case? So you can write mod of xy square is less than equals to x square by 2 plus y to the power 4 by 2. Right? So you can write xy square upon x square plus y to the power 4 mod is less than equals to 1 by 2. Right? This is your function z. Right?
Yes, sir.
Yes, sir.
Yes, sir.
So this is your bounded function. And by using the property, one function is bounded and the other is going to 0. So limit xy tends to 0, 0, f into z will be equals to 0. Right? Now I can give you some more examples. Okay, calculate this one. Limit xy tends to 0, 0, xy upon x square plus y square. Okay, so let me prepare this y upon x square plus y square. Try this one.
0, sir.
So someone is saying 0. Okay, why?
So we'll just simply
Check
change
whether
1
limit
by
is
x
exists
square.
or not.
So because 1 by x square plus y square is always less than 1 and y is our g
Why,
of x.
why? You are saying 1 upon x square plus y square is always less than equals to 1. So just take x equals to 1 by 4 and y equals to 0. Even this is not a bounded function. You give me any number, I can give you a value of x and y such that that value will be larger than your m. This is not a bounded function. This is an unbounded function.
Limit does not exist.
Does not exist.
Okay. So what path you have taken?
Y equal to
Y is
mx.
equal to mx.
We can also take
Y
y
equals to mx. So y equals to mx you have taken. Then
or y equal to x.
y equals to
X.
that is already in y equals to mx. Take m equals to 1. Y equals to x is already in y equals to mx. So
Just
you are
take
saying y
when
equals to
we
mx. So
limit
let's
does
try
not
with
exist.
this function. So this
When
will
we
be limit xy tends to 0, 0. Right? So this will be mx. This will be x square. This will be m square x square. And this is going to actually infinity. And what other path you have taken? Okay, you can say the limit does not exist in this case also. But better is okay, yeah.
So can we take y is equal to m times x square plus y square?
Yeah, you can take. The point is this
Then
point
sir limit does not
this point must contain in your path. You can take any path. It's up to your choice. But this point must contain in that you are taking y equals to
In bracket x
x.
square plus.
Tell me that path. X square plus y square.
Yes.
Right. So your 0 0 is containing this is available in this path. So you can take this path. No one is stopping you.
Yes.
Right. Now, but the better is you can take this path. X equals to m root y, or you can take y equals to x square something. So, or you can take y equals to m x square. Okay, so let me try with this path. This path contains 0 0. Of course, this is containing 0 0, right? So now calculate limit x y tends to 0 0. The path is y equals to mx square. So this will be m x square upon x square plus m square x to the power 4, right? Take x square as common. So what will you have? M upon 1 plus m square x square, right? Now, there is no y. So you just take limit x tends to 0 because m is not available in the function. M square x square. What is this value? This is equals to m, right? Now take m equals to 0, then this limit will be 0. Now if you take m equals to 1, this limit will be 1. If you take m equals to 2, the limit will be 2. All are not equal. So you have too many paths. Right? So limit along this path. Limit does not exist. Right? This limit does not exist. Right? So I think we can now solve some previous year questions. So I have some previous year questions. So plan is 22, 22, 50. I hope you are understanding what I'm saying.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is the question. So they have asked in 2022. So I'm not able to write this question. Okay. I don't have any access to edit this file. So I can write here. So function is, let me write here. Because I downloaded that file from the site and now the file is saying you can't edit this file. Function is hxy is equals to minus 1 upon x square minus y minus 1 upon x square minus y. When x square not equals to y and 0. And 0 otherwise. This is your function h. Now what is your function f? F is sin x upon x. This is your function sin x upon x. If x is not equals to 0, 0 if x equals to 0. This is f of x, one variable function, right? Now these two functions are given. So the first option is find the limit of root 2. It's difficult to write. Goes to root 2 pi 2 pi cos x square y upon x square plus 1. X square y upon x square plus 1. Okay. Okay. So you calculate this limit. Till then, I will double the options. You try to calculate this part. Till then, I will write all the options. And the remaining limit root 2 to root 2 comma 2 e to the power hx. Limit e to the e. So what's the value of first one?
Minus 1 by 2.
Hello, I'm not
Minus 1 by root 2.
minus 1
Minus
by
1 by 2.
root 2.
1 by 2.
2.
Minus
1 by
2.
okay, 1 by 2.
Minus 1 by
Okay. So how to calculate this part? So cos is a continuous function, right? So cos this will be equal to limit xy tends to root 2 pi x square y upon x square plus 1, right? So the first numerator part is going to, so the upper part is polynomial, right? So if you put x equals to root 2, that will be 2 pi equals to pi, so 2 pi upon. So denominator part will give you 2 plus 1, right? So the limit will be cos 2 pi by c, right? And you can write cos 2 pi by 3 as pi minus pi by 3, right? This will be minus cos pi by 3. So this will be equals to minus 1 by 2, right? So in the question, so they have asked the first option. So this is true. they have asked for false, right? So the first option is true. So now try for second one. So this one is true. Try for second one.
Second one is 1.
Second one is 1. So exponential is a continuous function again.
Yes, sir.
So how to solve this function? So exponential is a continuous function. So you can write this as a e to the power limit xy tends to root 2 comma 2 hxy. Now what is hxy? This is this part, right? So when you can write this function. So we are
square
checking
equal
at
to
root
y,
2
so
comma
x
2.
square equal
Hello?
x square equal to y, so hxy will be 0.
Not getting you. Let's see what will give you. So
Sir,
this will
here,
be e limit
here x
xy goes to root 2 comma 2, and this value is minus 1 upon x square minus y. So you can observe that this part is going to towards infinity, right? Because x is going to root 2 and y is also going to 2. So this is going to minus infinity, right? And e to the power minus infinity is this is
It is
0.
x square is equal to
0.
y.
Why? What happened?
सर जब x square equals to y then question में उसको 0 दे.
So
But
see, we are checking at limit at root 2 comma 2, right? So we are not interested at what is the value of f at root 2 comma 2. We are not interested in this point. We are interested where this function is going. So we are that's why we consider this part, right?
Okay, sir.
So this is 0. So this value is 0. So what's the
But sir,
option?
here x square is equal to y.
So in that case, sorry, what you are saying?
Sir, I was saying that here x square is equal to y, so we can take age of xy equal to 0. So it will be e to the power 0 and it will be 1.
Root 2 comma 2. Okay, this is your point. Suppose root 2 comma 2, something like that. We are approaching that point. So let's try third one, then we will come back to this part. So you try this one. This is your greatest integer function. This is your greatest integer function. Let me think about the second part. I think you all know about greatest integer function. So that means uh, if you have 3.1, so this will be equals to 3. So like this type of function, 0 to 1, then 1 to 2.
Ladder, step function.
This type of function you have. You try this third part and
0.7.
what will happen?
0.7.
0.71.
Yes, sir. E minus 2. It's correct.
Yeah, of course you can take this part. Yeah. So if you take this part, okay. So if you take any path in this case, so if you take any path which is not of this form, the limit will goes to 0. And if you take this path, then of course this point contain root 2 comma 2, right? This is the point where we are calculating the limit, right?
Sir,
And along this path, hello,
sir, may I say something?
sorry.
Sir, actually you are right at this point under root 2 comma 2. It will be 0 only because it satisfies x square equal to y.
So what will happen?
So the function,
You can
if
take
it
any
is
path, na?
sir, if you are taking root 2 comma 2, then it will directly get
Okay.
to 0 because x square equal to y. So you don't need to take minus 1 upon x square minus y. So technically you are right.
No, the what she was saying is if you take this path, right? This is your path, right?
Yes,
Suppose
sir.
this is your path. This path also contain the point,
Yes, sir.
right? And if you apply limit, so along this path, value of this function will be equals to e to the power 0 along this path
Yes,
because you
sir.
have chosen this path, right? You can choose this What's wrong in that? You can choose this path. This path is correct because it's also contain this point.
The limit will be 1 or 0, or limit does not exist.
So this will be equals to 1,
Yes, sir.
right? So so in this case, limit will not exist.
So please explain again question number 2. I can understand.
Okay, let me explain this part again. So if you take any path, so let me write this again. So you are checking limit x y tends to 0 0 e to the power, okay, h x y, right? Although you are able to use this the property if the limit of h is exist, right? So e to the power x is always okay. So suppose you choose this path, okay. So suppose first you choose this path y equals to x square p1, okay. Then what is the limit of what happened? One moment. Okay. So suppose you have taken this path, right? Along this path, what is the limit x y tends to 0 0 h of xy? What is the limit of this function along this path? along this path, this limit is actually 0 because function is hxy equals to minus 1 upon x square minus y if x square not equals to y, right? And 0 if x square equals to y. Now I have chosen this, right? So along this path, function is equals to 0, right? So limit of this function, this part is equals to 0 along path P1, right?
Yes,
Yes,
sir.
sir.
Yeah, are you getting me? Hello?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So along this path P1, so this limit is 0 because value of h is 0 along this path, right? So because limit is exist along this path, I can use my property. E is a continuous function. You can use this property once you have the limit exist. Otherwise, you can't use that property. Now along this path, I'm saying limit is exist and equals to 0. Now along this path, I can use this property, the continuous function property. So along this path, this will be equals to limit xy goes to 0, 0 e to the power h xy because limit exists along this path. I'm doing everything along this path, right? So this will be equals to e to the power, and this limit is 0, and this is equals to 1, right?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
now take this P2 path. Now take this path y equals to 2x square, right? So
Sir, root,
what can you do
sir,
is,
sir. 1 second, sir. Sir, root 2 comma 2 will not pass through this point, no? Then how can we take this?
okay, so okay, our point is root 2 comma 2, right? So if I take this path y equals to, oh, again this won't work. So if I take any path which contain this point, the point is you can,
So
the point is,
2x root of 2x y equals to.
yeah, something you can do something like that. Y equals to root 2x, something like that. You can do that, right? The point is, suppose you have this x square into y. That means you have a parabola. Now you choose a path which is different from this parabola. This path will work. Y equals to root x, 2 root x. You take P2 equals to this path. So if you take x equals to root 2, so this path contains root 2 comma 2, right?
Yes, sir.
Yes, sir.
Yes, sir.
Why it is not contain root 2 comma 2? Is satisfying this point.
Yes, sir. Yes, sir.
It will contain this point,
Yes, sir.
right?
It will.
Yes, sir.
Now, along this path, so if you take this path, so y square, so the function is x square is not equals to y. So now if you take x square, now if you take, so along this path, you can say x square is not equals to y, right? It's not, there may be some points where x square equals to y, but not for all the points. You will have some points where x square not equals to y, right? Now check along this path, right? So limit xy tends to, so say root 2 comma 2 along this path, this path, P2 path. So let me erase the extra path. So now the path is y equals to root 2x, right? Now along this path, limit xy tends to 0, 0 h of xy. This will be equals to limit xy 0, 0. Now, what value we should check? We should take this one, this value. So this will be minus 1 upon x square minus y, right? So value of y equals to root 2x. So you can take limit xy tends to 0, 0 minus 1 upon x square minus 2. Okay, 2x square, right? So this will give you limit
Sir, it is x square minus y now. So root 2x only. X square minus root 2x.
okay. This is root 2x. Okay, thanks. X square minus root 2x. Okay, so we can write this as minus 1 upon x into x minus root 2, right? When now there is no y, so we can write as x tends to 0. Now this part is going to towards minus infinity, right? And you know, if this part is going to minus infinity, then e to the power, this part, limit x goes to 0, is minus 1 upon x minus root 2. This will go to 0, right?
Yes, sir.
Right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So that means along this path P2, we have limit 0, right? Along this path P1, we have limit 1. Both are not equal. So limit does not exist. So in this case, limit will not exist, right?
Yes, sir.
So this is not 0. In this case, limit won't exist. I think, I hope you are getting this.
Yes, sir. Yes, sir.
Okay, then now try the third one. This one is easy.
Third one is e minus 2,
So
correct?
in our domains, so let's do it quickly. So let's solve this part. So limit xy tends to e comma e ln x to the power y minus greatest integer function y. Okay, so this will be equals to, so ln is a continuous function in our domain. I'm not talking about the whole R. I'm talking about the point where we are calculating the limit. So we can swap the function with limit, and again x limit xy goes to e to the power e x to the power y minus greatest integer function yy, right? So as xy goes to 0 e to e, then this part y minus this part limit xy when this goes to e. So this is a greatest integer function, right? This part will go to e, right? This is a greatest integer function. So e means 2 point something, right? So this will give you greatest integer 2. Hello? So this will give you e minus 2, right? So
Yes,
you at the end, what happened?
yes, sir, correct.
So you will get ln. So now again, now if limit xy goes to e, then x goes to, and if this is x, then this will goes to e by algebra of limit. So this will e to the power e minus 2, because both the limit exist, right? And this function is continuous in the domain, so we can swap the limit. So this will be e minus 2, because this is ln, this is e, so the answer will be e minus 2, right? So this value will be e minus 2. So let's check the answer. So this is e minus 2, right? This is correct, right? You try to solve this part. If you have any doubt, you can ask me in the next session, right? Similarly, try to calculate this part. So limit x comma y goes to 0 comma 0 e to the power 2y gx,
So it will be
right?
1.
So what is gx?
Sin x upon x.
Okay. That is gx. This is not f, actually this is z.
It will be limit does not exist.
So let me check. So limit xy goes to 0 0 e to the power 2y. This will be equals to, so because e is a continuous function, this will be limit xy. Okay, again. So we are talking about this. Okay, so you can check this function. So we are doing everything with respect to this function. So you can check this function. So 1 upon x. So okay, you calculate this limit x tends to 0 sin x upon x. So this will be
1.
1. Okay, and x equals to 0, what we have? 0. Okay, so okay, so limit exists.
Yes, sir.
Limit of this part is exist and equals to 1, right? So exponential is a continuous function, right? So gx. So what we can say, xy. Okay, you can see this part as, so it is e to the power into gx dy. Okay, this is into gx. Okay, so limit, so as we have seen, xy tends to 0 0 gx. This is sin x upon x, right? This is limit xy tends to 0 0 sin x upon x. There is no y, so you can just take x tends to 0. This is equals to 1, and this limit exists, right? Similarly, limit xy tends to 0 0. If you take e to the power 2y, so e is a continuous function, right? So you can write limit xy tends to 0 0 to y. Okay, so limit of this part is, this is polynomial, so this is 0, e to the power 0. This is 1. So limit of both the part exist. So by algebra of limit, xy tends to 0, 0. Product, you take product of these function e to the power 2y into gx. This will be 1 into 1. This will be 1. Right? So the answer of this is 1. So now the answer is 1. So this is true. This is true. This is also true. This is also true. This one is not true. B part is not true. We have asked for false statement. Right? All three are A, C, and D are true, but B is not true because limit does not exist in this case. Right?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
I hope you are getting what I am trying to explain you. So in this part we will solve some more questions. Previous year, of course, previous year GM questions, and of course we will talk about partial derivatives and total derivatives. And if time permits, I will talk about maxima and minima of several variable functions. I don't know Lagrange multiplier is in your syllabus or not. I am not sure actually. So I haven't seen the exact name in your syllabus, the Lagrange multiplier, but it also used to calculate maxima and minima of several variable functions. So I will check whether it is in your syllabus or not, and I will stop with that. Thank you for your attention.
Thank you, sir.
Thank you, sir.
sir.
Thank you, sir.
Thanks a lot, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Participants, if you have any queries, please ask. There were one or two questions in the chat box. I'll just read. The first question was how to find maximum and minimum possible delta for which limit exists.
So it may happen that for one delta, you can find infinitely many. Sorry. For one epsilon, you can find infinitely many delta. So if you have one delta and uh, you have your delta is working, so that's good. Don't worry about other deltas. It may happen that infinitely many delta works for one epsilon.
Okay, I hope the doubt is clear. The second question is how to identify bounded function.
So for that, you need to check that function. For what function you are talking about. So if that function is looking nice and you can prove by hand, that's good. But if there are functions which are not easy to prove that they are bounded, they are still bounded, but it's not easy to prove that they are bounded. It will come by practice only.
Okay, and we have one more question which says that what will be the value of greatest integer function of exponential function?
So exponential function.
Yes, sir.
So it will be composition of two functions. It depends on your x. Suppose you are taking x equals to 1. So e to the power x will be e. So that is around 2 point something. So greatest integer of that is will be 2. And now if you are taking x is more than 2 and 3, then it will depend on your x. You can't say that you will get a constant value. It depends on your x. And if you are talking about e to the power greatest integer of x, then you will have for every integer, so say m, So for every x in between m and m plus 1, you will get e to the power m. So it depends on what type of function you are talking about. You are talking about greatest integer of e to the power something, or you are talking about e to the power greatest integer of x.
Okay, sir. I'm not sure if the one who has asked the question is right now present. Thank you
Okay.
so much, sir, for your time and for such a wonderful lecture. Sir's lecture now, the second session will be on 16th January. Participants, please note that the Zoom link for tomorrow's session is already updated in the doc which was shared to you in your mail. So please check for the Google Doc. No new Google Doc will be shared with you, or no new mail will be sent to you with a Zoom link for tomorrow's sessions. The Google Doc which was already shared yesterday in a mail, in the same Google Doc, new link will be updated every day for each day session. Okay, so please make sure that you open the Google Doc and click for the correct Zoom link. And one more point I want the participants to note is that please join the Zoom only using your name. Please don't put any mobile phone names or anything, because that won't be counted as your attendance. Then later on, during giving certificates and all, it will be a problem for you. So please make sure that you have put your name as your Zoom name. Okay, that's all. Thank you very much, sir. I think we are ready to wind up then. Thank you very much. Thank you, participants.
Thank you, ma'am.
Can I left the meeting?
Thank you. Yes, sir. Yes, yes.
Okay, thank you.
Yes.